Hello viewers, welcome to this video lecture series on analysis and design of algorithms. Today's topic of discussion is on mathematical analysis of recursive algorithms. So previous two sessions we have seen mathematical analysis of non-recursive algorithm. Now in this session I shall take an example to demonstrate the analysis of a recursive algorithm. In the program, when you are using this approach, the recursive approach, whatever are the number of operations you are carrying out for the main task, the same set of operations are applicable for the subtask also. Basically your problem is getting divided into subtasks, and what operations you have written for the main task, same set of operations you want to apply it for the subtasks or smaller task. So in simple terms, a recursive function is a function which is going to call itself within its definition, allowing its operation to get repeated in a self-similar way. So let us demonstrate this now with an example. You have various algorithms to demonstrate the analysis of recursive approach. The one which here I have chosen is the Tower of Hanoi. This is the popular problem. It is a puzzle. Okay, what exactly is the problem and what is the solution? I shall explain to you in detail. So to demonstrate this, I shall start with a very small value of n here. So the input is the number of disks that are used here in this puzzle. Also, I demonstrate the functioning of this algorithm using the recursive tree, and in the last part of the session, I shall carry out the analysis to come out with the time efficiency for this algorithm. So the problem is like this. The title of the problem is Tower of Hanoi. Okay, you have three towers. Three towers are given. Okay, and the job here is there are disks that are placed in the first tower. Okay, and you can see the size of the disks. The disk that is placed at the bottom is larger. Then little smaller will be the next. Like this, on the top you have the smallest disk placed. The job here is to transfer this disk to the third tower, and you are having three towers, so let me name the towers also 1, 2, 3. All the disks initially are placed in the first tower, so we can call this as the source tower, and you have to transfer it to the third, which is the destination tower, being given an auxiliary tower also here, so that you can make use of that tower. But finally your job is to transfer this disk, and when you transfer C to that, always the larger size disk should appear at the bottom. That means in the same fashion you are going to place it. No bigger size disk should appear on a disk which is smaller. Like you cannot place like this. You are placing one smaller disk, then one bigger, then one intermediate size, then smaller. Like this you cannot place. The same order should be placed here. For this to carry out, I'll just show you with one simple example. Initially what I'll assume is, I'll assume the problem to be very smaller problem. Smaller problem here is only one disk is placed. Okay. What I'm trying to tell is there is only one disk that is placed in the first tower. You are being asked to move this disk to the destination tower. So this is the simplest job. The number of disks that are given here is only 1. So n value is 1 here. N equal to 1. And your job here is to transfer it to the destination tower. One disk present here, I can write down step here. One step here, move disk from 1 to 3. You are simply moving the disk from 1 to 3. Only one move is required. We'll see one more case wherein two disks are given. Okay, like this. These are the three towers. Now these two disks you have to move it to the third tower. How do you carry out? And you have to see that the larger disk will be placed at the bottom, the larger size disk. So first step will be move disk from 1 to 2. You are trying to first move it to what? To this. Okay, this disk. So that means you have moved this disk here. This is the first step. Fine. Then what you will do is move disk. Second move is what? Move disk from 1 to 3. The second move is directly from the source to the destination. The first move you are making use of the intermediate tower. Now we'll see. So in the second move, what will happen? This disk is coming to the destination tower. Okay, it has come to the destination tower. Now third step, what you will write? Move disk from 2 to 3. 2 to 3. So when you write this third step, this disk that was in tower 2 has come to, so you have successfully done your job. you required how many moves here? 3 moves are there. And when you are writing the steps for the moves, when you are writing the statements for the move, remember one thing, whenever you are making a move directly from source to destination, like this one, 1 to 3, okay, you simply write 1 to 3 only. Whenever you are trying to move from 1 to 2, which is not the source to destination, here also this is not the source, this is not the destination. So that time you have to use the statement like this: move disk from 1 to 2 using 3, move disk 2 to 3 using 1. Now we'll try to go to a larger size problem. Larger size problem here is n equal to 3. We are taking 3 disks. Moreover, n equal to 3 disks itself becomes a bit larger now, because we'll see how many moves you require here in order to carry out. And suppose sometimes in the statements, if you want to number this as instead of 1, 2, 3, you can write it as A, B, C also. So this is like A and C. So this is like A, B, C. This is like A, C. This is this is B, C and A. So only thing, so this way also you can write down if you are numbering the towers as A, B, C. The reason is in the algorithm, okay, for this function we are using the variables A, B, C. That's the reason I want to relate, so don't get confused. Here in the explanation I have used 1, 2, 3, but in the algorithm I am using the variables A, B, C. A, B, C denotes what? All the 3 different towers. And the very first parameter that is passed here in this function is n. N indicates number of disks. So in this example, we are having how many disks? 3 disks. So our n value is 3 here. Okay. N value is 3. Now we'll carry out for 3 disks. 3 disks, what I'll do is, in the first tower, this is the first one, this is the second one, this is the third one. 3 disks are there. See, how to write the moves for the 3 disks. When you want to write the moves for the 3 disks, to move these 3 disks, what we can do is, out of these 3, suppose if you want to move this first 2, for 2 disks, the problem which I discussed earlier was only for 2 disks. So for 2 disks, you wrote these steps. Now the same 3 steps will be applicable definitely to move these 2 disks. So how will I change now the statements? What I'll do is, if you want to carry out those steps are same for this movement of 2 disks. So here I'll write move 2 disks from 1 to 2 using 3, move a disk from 1 to 3. So this one is just moving what? The disk from the first one, move 2 disks from 1 to 2 using 3. Those 2 disks are here. And the second step is move a disk from 1 to 3. So this bigger size disk has come to third tower, 1, 2, 3. Then the third step is move, this is disk, sorry, move 2 disks from 2 to 3. So whichever you had moved earlier, those 2 disks will come over here. You are following the same procedure to move the 2 disks. So you are able to place these 3 disks in the same order in the destination tower. So what we have done here is, basically for 2 disks you had followed some procedure. Now the same procedure you follow here also. Given are 3 disks, so what you are doing is same procedure you are following it for the 2 disks. So in the first step what we are doing is, we are writing 2 disks here. And the second statement will have only one move, wherein from the source to the destination. Then once again we are using the third step here. If now, since you had 3 disks, you are writing move 2 disks. Move 2 disks. Suppose if you have n disks, then this will be what? N minus 1. N minus 1. So what I can do is, the same 3 steps are applicable for me if I am having n disks. So I have to write here, move n minus disks from 1 to 2 using 3. Move a disk from 1 to 3. This will be only what? 1 disk movement from 1 to 3. Then once again the third step, move n minus 1 disks from 2 to 3 using A. So these 3 are the main statements here to carry out to move the n number of disks from the source tower to the destination tower. These 3 steps. Let us carry out these steps in a recursive manner using the tree. So here I will write down the function. The main function, the first time the function used here is for n, okay, and you have what? The 3 towers, 1, 2, 3. In our case, since we are using n equal to 3, that means the number of disks are 3 here. So the n value is 3. So now don't get confused. The first parameter is the number of disks, and this 1, 2, 3 are the 3 towers. So there in the algorithm I am using ABC. Here I am just writing 1, 2, 3. So this function, okay, will make a call that is a recursive call. So to carry out this job, to make these 3 disks move to the destination tower, because here this first number represents the source tower, the last number represents the destination tower. Okay, to carry out this job, what you are doing is you are writing these 3 steps. First one is move n minus 1. So that is your function now, move n minus 1. N minus 1, now n value is 2. Move n minus 1 disks from 1 to 2 using 3. 1 to 2. In this case, 1 becomes source and 2 becomes destination. So while writing here the parameters, first parameter will be your source, next the last one will be your destination. Using 3 is what here you are writing in the middle. Okay, that is the middle one. So this is the middle. Hope you are understanding. Okay, first 3 are the towers to carry out the movement from the source to the destination. The first move is here, move n minus 1, n is 3 here, so this becomes 2. First step what you are doing is you are moving 2 disks from 1 to 2. So 1 is source now, 2 is destination, and 3 is the in-between tower. After that, second, move a disk from 1 to 3. So this is a simple printf statement, so we can write here 1 to 3. And the third statement is the function again. You can call this function move n minus 1. So once again we are calling this tower of ni function. The value of n minus 1, that in place of n minus 1, 3 minus 1, 2. From 2 to 3 using 1. Look here, from 2 to 3 using 1. Then what is that you will write? 2 to 3. 2 is your source, 3 is your destination, and the auxiliary tower is 1. So this way the first level of the tree you have constructed. But you cannot stop it here because your value of n is 2 here. You will be carrying out this as long as n is greater than 0. Okay. Once n becomes 0, then the algorithm will stop. Let us see when it stops, what is the status. Are you able to move all the 3 disks to the destination tower? That you need to check at the end. Now at present, hope you got to know. These are the 3 main important steps. Fine. We have written here. Shall I shift this to center of the board? So I am just placing that diagram at the center of the board to give a clear visibility. So this is the first level of the tree. You have to continue as long as n is greater than 0. Now you are here. Once again, for this function it will get divided into 2 sub-functions. And the first one, how will you write? The first step, move n minus 1 disks from 1 to 2 using 3. See, 1 to 2 using 3. Now whatever is 1, 3, 2 here in this function, this is your ABC. Fine. Now for this ABC, you have to carry out move from A to B using C. A to B is what? 1 to 3. So your source is 1, okay, and destination is 3, and the in-between tower is 2. This way you have to analyze and write down the parameters correctly. TOH, and the value of n is what? 2 minus 1, because next time it will become n minus 1. So 2 minus 1 is 1. So you are having n value 1, source tower 1, source value 1, destination 3, and in between is 2. What is the second step? A to C. Now at present A to C is 1 to 2. So here it will be 1 to 2. And what is the third one? B to C using A. Your B value is 3 here, okay, and C value is 2 here using A. A is 1 here. So B to C. B to C means your source is 3, destination is 2, and your in-between tower is 1. What is the value of n? Definitely it is 1 only. So the function name I will write down 1 to 2. So like this you have to carry out. Now next time when you move towards your right hand side, you have 2, 1, 3. So 2, 1, 3, once again you write here. Now your 2 is A, 1 is B, 3 is C. So you follow the same steps what you have written here in order to pass the parameters for the next level of functions. You have now 3 statements here. The first one is the function, the second is the printf statement, and the third one is function. Now correctly pass the parameters, write the function name. Now to n minus 1, 2 minus 1, n value is 1. Okay, now you have to correctly pass the parameters here, which is the source tower and the destination tower. So already I wrote here 213. See this 213, I am writing it here 213. What is the step? A to B using C. Here A is this one, 2, B is this one, A to B. So I'll write here A is 2 and B is 1 using C. C is 3. Okay. Next, what about the next statement? 1 to 3. 1 to 3 is A to C. A to C is what? A is 2 and C is 3. Now your 213. 213, your ABC values are what? 213. And for this function, move n minus 1 disks from 2 to 3 using 1. Move n minus disk from B to C. Move from B to C using A. So B is 1, C is 3. So your source is 1 and destination is 3 and in between is 2. Value for this n is 1. So you got the parameters in this manner now. This is the second level. Now you are moving to the third level of the tree. So because it is a recursive function and you will be calling, the function calls itself again and again as long as n value is what? Greater than 0. Now at present n is 1. Okay. First level of the tree n was 2. First level of the tree n was 3. Okay, second level of the tree n is 2 and in the third level of the tree n is 1. Now 1 minus 1 0. Then the algorithm will stop. It will not call the function again. So for this case what will happen? This is not applicable. The printf statement 1 to 3 from source to destination. This one you just say A to C. Your A is this, C is here. A to C will you can write down 1 to 3. Once again here this function is not applicable, n value becomes 0. Then here, what about here? Same thing is there, not applicable, n value becomes 0. A to C, your A to C is what? 3, 2. And what about this one? Not applicable. Here, not applicable, A to C. So your printf statement 2, 1, this move you have to write down. Then not applicable. Here, not applicable. Printf statement A to C 1, 3 and here not applicable. So this way, now at this level the algorithm stops if you are taking n equal to 3. What you have to do is to collect the moves, you have simply collect all the printf statements. Suppose if I am writing all the printf statements in the sequence, then start from this side. Okay, first 1, 3. 1 to 3 is your first move. Then 1, 2. 1 to 2 is your second. Okay, and then 3 to 2. Then fourth you have to take like this. Okay, start like this completely whatever are the printf statement towards your left side function. Then comes this one 1, 2, 3. Then towards your right side, the very first one is 2, 1, 2 to 1, 2 to 1. Then comes 2 to 3. Then comes what? 1, 2, 3. Okay, how many? 1, 2, 3, 4, 5, 6, 7. 7 moves are required finally here to move these 3 disks from the source tower to the destination tower. We shall use these 7 moves. So your initial problem is here. To identify the disks, I will write down like this. This is X, this is Y and this is Z. Okay. Just to get the clarity, I will name the disks also. So your 3 disks are here. First move is what? 1, 2, 3. 1 to 3, this Z will come over here. 1 to 2, this one will come over here. 3 to 2. 3 to 2, what will happen? 3 to 2, this Z will come over here. So you have completed 3 moves. Then 1 to 3, 1 to 3, this bigger disk X will come over here. Then 2 to 1, 2 to 1, this topmost disk will come over here. This you have completed. Now 2 to 3. This one y will come over here. Two to 3 is over. Next is last is 1 to 3. One is z. So one is z. That z has gone to the 3. So this is how you are able to successfully transfer all the 3 disks that were placed in tower 1 to the destination tower 3, and it should be in the same order, in whichever order it was initially given. And for this to carry out, you needed 1, 2, 3, 4, 5, 6, 7 moves are needed here. If your number of disks keeps on increasing, then definitely the number of moves also keeps on increasing. You have to check here the time efficiency of this algorithm. Since it is a recursive function and the analysis is also having a different approach here, because you have to write down the recurrence relation here. Recurrence relation, how to write, that I'll explain, and then I'll give you the simplification. So since the video is becoming quite lengthy, in this session I have explained you the logic for the tower of Hanoi problem using an example, and in the next session I shall give you the details of the analysis, how to carry out, how to find the time efficiency for this problem. So just have a look at the pseudocode for the tower of Hanoi. This is how you are going to write. As long as n is greater than 0, you are calling this function. Okay, you can see here, this is your main function, you have called it. These three statements, whatever you have written, these are the 2 functions which are appearing here, and the printf statement is here. So this keeps on getting repeatedly, the function calls itself until the n value is greater than 0. In this session I have explained you the pseudocode for the tower of Hanoi problem and the logic to understand how to make moves here in order to complete the task, and the analysis part I shall start in the next session. Hope you find this session useful. If you find it useful, please like, share and subscribe to my channel. Thank you, bye bye and take care.